Hello, I am Dr. Gorgon, and today we're going to discuss use of C files. So we're going to be using Replit for that. It's not that I'm expecting you to do this necessarily on Replit, but it does happen to be a platform that is convenient, easy to use, and will compile a remarkable set of languages. So today we're going to be discussing just a few pieces and components of a initial main C file. The first piece of it that you may have seen before in another language are the preprocessor directives. So not every piece of code is going to be something that you yourself have written. Some of them are going to be from shared libraries. When you need to use shared libraries, it's actually these preprocessor directives that are going to bring in the necessary code. So in our case, we are utilizing stdlib.h. This is what gives us functions like srand and rand. And then when we utilize stdio, we're going to use that quite frequently because it is what gives us the ability to use the printf function and therefore show output. The second major component of your first program in C is going to be the creation of a main function. So if you use this as an int main function, you're going to need to return some value, and 0 is appropriate. Inside of the main, you may or may not actually have anything, but if you have put arguments inside of your main function, it is typical to have a first argument that is the number of arguments that came in on the command line when you execute your code. And then we have a char star argv with square brackets, which can also be reframed as a char star star without losing any information. You can treat this as being a two-dimensional array of characters, or you can treat this as being an array of strings. The C language does not really have string variables, not as a basic type, but this is something that you can utilize as if it were an array of strings. So when we run our code, what it is doing is it is going to seed our random number generator. This is going to utilize the current time since January 1st, 1970. This is going to result in every time we calling the rand function, a slightly different integer being created and generated that is not actually random, but pseudo-random. And the number that is going to result is going to be between 0 and max int. That could be significantly large because the int variable type can hold numbers that are up to 2 raised to the 32nd power minus 1. Whenever we use modulo on that, we are limiting the top number that it can end up being anyway. So this is going to produce a random number between 0 and 499. And then when we add 1 to that, that changes the range to between 1 and 500. So all our code is going to do then is use the printf function in order to print out that random number. But it's not that easy. We also have to format our output. So we could just have done printf hello world and we're done, but that's not as interesting. So instead we are going to print out this random number. In the C programming language, generally speaking, the printf function is used for many different kinds of output. It can have just one argument, in which case, generally speaking, you don't have this percent sign in it. If you have a percent sign in your first argument, that means that for each percent sign you have, generally you have at least one more argument. So when you use %d, that next argument is expected to be an integer, and it's going to be shown as a signed integer. So we could just press this big play button, and when we do that here in the console, we are going to find that it will run. But it's also worth it to know how to deal with this when you don't have access to Replit. So turns out you can actually put the code that's in this Replit, which, by the way, you can find at replit.com/@drgorgon/hello-world and then you can put in the hashtag main.c, but you don't have to. You can copy and paste this into any text editor. The text editor itself is not the important part, as long as you have it saved. So on whatever computer you are utilizing for this, you have to have a C compiler. GCC is the one that I prefer to use. If you just want to compile it, you can use GCC and then the name of your file. So look, this one happens to be main.c. When you press enter, it's going to, generally speaking, compile for you. And we can check our files and say, hey, there's quite a lot of files in here, but one of them is this a.out. A.out is green because it is an executable file. So we can actually run a.out. Some will do that. Sometimes it will be fine. If you put in /a.out, though, it always works because even on architectures where just running this command will do the job, if you put the / in front of it, it's not wrong. It just means that it's going to look in the current directory before it goes to look elsewhere to run your code. So notice that when we ran it, it's printing out hello world, and then it's printing out a number 202. And when we run it again, it's going to give us a different random number that we printed out. Some of you may be curious about this whole main that's also green, and yes, that is also an executable. So how we create that is when we go back to this GCC main.c, we're going to add a dash and a lowercase o, and then we can call it main. Now, many architectures allow you to use tab completion at this point. I recommend not doing that when you are putting in the name of the file that you were trying to generate through compilation. It's too easy to overwrite your own code this way. So we leave off and we just do the main, and now we can run /main with the same output expectations. All right, that's all for this first Hello World video. Check back in and there may be more.